What's up, everyone? John here, lead maintainer of the open source software engineering education platform, Ladderly.io. You can sign up for free and get access to the career journal. You can also check out perks, the blog, and the rest of the site. I just published an article on backtracking today, and we will be doing a couple backtracking problems. In the current stream, letter combinations of a phone number. So let's dive into it. So the problem says, given a string containing the digits 2 to 9, and why would it be 2 to 9? Because we can see on this phone pad, 1 has no letters mapped to it. Similarly with 0. So we're going to go 2 to 9, and that's inclusive. Return all possible letter combinations. Whenever I see a phrase like this, all possible combinations, I'm thinking backtracking. So combinations and permutations are a clue that backtracking could be a useful technique. Okay, so all possible letter combinations that the number could represent. So you can see how there could be multiple combinations because consider the number 2, it could be A, B, or C. So 2, 3 could be, AD, AE, and so on. Actually, that's the example here. 2, 3 could represent any of these bad boys. All right, and we can return the answer in any order, So that is a bit redundant with the term combination. So a permutation is order sensitive. A combination is insensitive to the order. But it's nice that they just made that super, super, super clear. Return the answer in any order. And this is going to look like an output list rather than a set, although I might be tempted to use a set for combinations. I think I might try to do it both ways. Oh, no, it says list here. Okay. If it didn't specify the return type, I would probably try to return it both ways just to see what LeetCode did. But they're asking for a set. Or sorry, they're asking for a list. A mapping of digits to letters is given below. Cool. All right. And then if it's empty, it's empty. Got it. So let me make a map here. And this will be the string integer to letters. Okay. It's a string integer to letters. I'll do this as a list because we can look up the So I guess it'll just be integer then. Integer to letters. Because we can look up the key as an integer since it's a list. You could use a hash map. You could use a dictionary. I think it'll be fine, but I'll do this. So here's 0, and then here's 1, and then here's 2. Okay, so in the case of 2, I'm going to say A, B, C. And I'm just going for lowercase, right? I don't see it specifically called out as a constraint. So we could deal with capitalization if we fail a bunch of cases and we see like capital letters. I'm going to assume lowercase. But actually the algorithm we're going to implement will work anyway. I would just need to say like ABC and then add, the capital forms. But the same algorithm, the same backtracking algorithm will work. It'll just hugely increase the latency, the runtime. So A, B, C, D, E, F. A couple of these letters have 4. They're not all 3. G, H, I. It'd be nice if they gave us this, because I feel like this is like the worst part of programming, right? This is the most monotonous thing that I could be doing. I feel like an accountant. And then O. And then you see PQRS. So we got a 4, 3, 4. Okay. 4, 3, 4. And then I think that should take care of our alphabet, I think. PQR. S. T, U, V, W, X, Y, and Z. We went to college for 5 years for this. Some of y'all got out in 3 or 4. Most of us got out in 5. But we got the alphabet down. Let me also do a quick check on the chat here, make sure I'm not missing anybody. Welcome in. If you're enjoying the video so far, give a like to the video so the algorithm will send it around. Okay, so we have this I to letters. So I'm going to get the digits in through the string. I'll cast them to an integer and then look up on this I to letters. And I want to create basically a DFS here. I'm going to call it explore. So let me go through the approach here. So backtracking approach. And we want to have digits. So n is digits and m is 0. No, it's not 0, 1. So we got 1, 2, 3, 4, 5, 6, 7, 8. Am I counting correctly? 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So m is 8 telephone digits. And so how many digits could they potentially send? The most digits that they can send is all the digits. Let's see, could they put 2 2s? Yeah, I guess they could, right? You could put 2 2s. Digits length is 4. Okay. Okay, so so time complexity is O of n. Or sorry, O of 1. Time complexity is O of 1 because it's a bounded search space. It's a bounded finite search space. More traditionally, what we would consider here, we would consider the combination math stinks, doesn't it? Okay, traditional combo math, time complexity is n factorial divided by m factorial times, let me put this all in parentheses, m factorial times is it n minus m factorial? It's n minus m factorial or n factorial minus m factorial. It's something like that. Or more loosely, n factorial is a boundary. So that's like a looser boundary, but it's actually going to be discounted because of the choosing logic. Well, is there reuse? That's the question. Is there reuse? Mapping of digits, note that one does. Yeah. So if there is reuse, actually, then I shouldn't be using an exclamation point. So the exclamation point is if it was like, roll a die, 1 through 6. And whatever you use, you can't use it again. So if I roll a 6, now I can only roll 1 through 5. So it becomes 6 times 5 times 4. That's the factorial operation. Do you see that? But if I can keep hitting 6s and that's valid, then actually it's just 6 to the power. It's just 6 to the power. It's a power set. So even though the examples are all unique input digits, I'm thinking there's no reason that they couldn't hit 333. Do you agree with that? There's no reason they couldn't hit 333. There's plenty of telephone numbers like that. So I'm going to modify this. This is not traditional combo time complexity. This is going to be m to the power of n. So in a binary, like flipping a coin, it would be 2 to the n. N is the digits. Okay. But here, it will be so OM, so O8, there's 8 options, and you can keep hitting them. So it'll be 8 to the 4. But you can see, once again, that is ultimately O of 1 because this is a constant. Okay, did I convince you? I convinced myself. That's good enough for me. Okay, great. All right, so we have this time complexity. You're not going to beat O of 1. Good luck. Die trying. And so what is kind of like the pseudocode implementation here? So I want to do backtracking. That means I need a path. So I need a path parameter. I'm going to DFS on path starting with empty path. I will, within DFS, iterate from each start index to each forward end index. So kind of like a sliding window, but not. I guess I wouldn't say that in an interview. So kind of like a sliding window. And can I prune? Can I prune? Yes. Yes. When the path length is greater than the length of the digits. When the path length is greater than the length of digits. So that will not change the worst case time complexity. I mean, it's constant time anyway. But in practice, that will speed things up a lot with that little check for pruning. How you feel, chat? We feel good? Let's do it. Okay, so here we go. We got results. It's this empty list, called DFS, and then we return results. All right. Now let's call DFS. I'm going to call explore, and this is going to be my DFS. And I'm going to call it with results, digits, and empty list, which is going to be path. So explore is a specialized DFS with a path parameter for backtracking. Okay, that's why I call it explore. I also like the term step, but that's a little more generic. Explore is like really specific to backtracking. So we got self, digits. What did I pass first, results or digits? So we got self, results, digits, and path. Self, results, digits, and path. Okay, so what do we want to do first? We want to do our guard. If there's no digits, we want to guard on that. We just return. What else? If there's no results, I don't care. What if there's no path? Of course, there won't be a path to begin with. But if there is no path, this example too, the empty string, there's no path. But I do still want to get, okay, it's an empty output. It's not putting in the empty string. Okay, I was going to think about appending a copy of the path right there, but I shouldn't do that. We want to leave it blank. It's non-appended. You see that, right? It's non-appended. Okay, so in the case of digits, in the example 2, I got ABC. We're coming down here. And so what I want to do is for I and range length of digits, I want to get the cur what? Cur options. Maybe it's cur options. Okay, cur options, which is now we're going to use our I to letters. And we'll put it on the path. Path.append. No, we can't, because that's going to be a list. I need to cycle through them. For C and cur options. Here, let me say for char. That'll make it a little more clear. I could say for letter, for char. And then we'll append the char, we will explore again, and then we will pop the path. And this is what makes it backtracking, ladies and gentlemen. This bit right here. You see how we're recursive, we're trying a step, we're doing a recursive operation. When that recursive operation completes, we pop. And then for char, we're controlling the left hand. So you see where I said down here, from each start index to each forward end index. Okay, so the way we navigate forward is we dive. But the way we modify the start is this iteration. We're good? Yo, once you get backtracking, it's good soup. It's good soup. Okay, so this is not yet complete. What do I want to do with cur options? I need to pass in the integer representation. Digits I. So here's the ith digit. I'll even call this cur digit. And that's the ith digit. And this would be like a 2 string, but I want the integer form, so I'm going to cast it. Okay. Don't forget, programming is magic for casting. We love casting. Well, I shouldn't say we love casting. There's lots of times you should avoid it. All right, I sit corrected. Okay. So I have my current digit. I'm going to look up the I. I'm going to look up the current options. So in the case of 2, I got ABC right here, right? And then I'm going through each char. So I'll be going A, I'm appending A and I'm exploring down, but then I hit this no digits because there are no remaining digits. That's the other bit I need to do. With this backtracking, once we append a step into the path, the exploratory set needs to be clipped because we want to cut and move it to the path. Let's see. Yes, because we're making our selection. So this is a 2 choose 8. So imagine I'm walking through a forest on a trail and I come to a fork in the road. I'm making my decision. And in this mental model, I'm exploring a whole path that's only 2 decisions long. Okay, so I need to mark somewhere that the remaining decisions has been shrunk. Make sense? All right, so remaining digits is the list of digits. Then we only want to explore forward indexes for each forward end index. So that is I plus 1. In the case of 2, 3, yeah, it doesn't really illustrate it very well. But imagine it was 2, 3, 4, 5. Okay, 2, 3, 4, 5. Once I take that 2 step, what are the remaining steps? It should start after the 2 and go all the way to the end. 2, 3, 4, 5. Okay, I wouldn't want to go 3, 4, 5 and like I wouldn't want to go 4, 5 and drop the 3. I wouldn't want to create a copy that included the one that I just used. So we want to do plus 1. That is our new starting index on the remaining digits. And then the end is the length of digits. We're going to go all the way to the end. 2, 3, 4, 5. Okay. So then we'll pass in results because we want to be able to add results whenever we want. By the way, I didn't add a result. I need to do that. Okay. We'll explore results. We will pass in the remaining digits, and then we'll pass in the path. Okay. And so now I've completed my DFS. So I'm getting the current options. I'm completing my DFS. The only thing that I think that I'm missing, of course, there's always the possibility that like I'm not thinking of something. That's the worst part for me, dog. That is the worst part for me. It's like I just didn't think about that. Okay. But assuming that I'm thinking about the things that I need to think about, then there's only one bit missing. The bit missing is when I actually append to the result. Let me take a sip of water. There are these 0-calorie drinks called Zevia. Not affiliated. Zevia, if you're listening, please sponsor me. But technically, I poured some water into the Zevia. And that's what I'm sipping. Okay. So at what stage do I want to append the result? my knee jerk wants to append it here, but I'm combating against this case. I could explicitly guard, so I could just do this only, I could just return early and guard that way. Here path is what? Path is a list. Maybe I should have made it a string, yeah? Okay, so I could just append it only if it's truthy. That's a really simple guard. That's a really simple guard. No, I like to keep it a list so that I can pop. Let's see. I guess you could do it with a string, but this is fine. So only if it's truthy. If not, digits will be the second check, because we might be at the terminal node of a DFS and there are no remaining digits. So when we pass in remaining digits, it's aliased as digits on the next call and the recursive call stack, okay? So there might be no digits, which is no need to forward process. So we'll jump out, but before we jump out, I want to store my result here. If it's truthy is going to be the trick. So if path. So if not path means it's going to be an empty list, that would be the falsy case. So if there's any letters in there at all in Python, it will be truthy. Then I want to say results.append join on empty string, and the value to join is path. I think I have that syntax right. JavaScript and Python kind of flip the array joining syntax, but I think I have that right. Explore is not defined. Okay, my bad. Should be called self.explore. Self, because we put it on a class. And I don't want the ellipsis there. Okay. Explore is still not defined. Okay. Because I put it on self. Sorry. And now I have a wrong answer. Dun, 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 dun. So what's my problem? My problem is that I missed the single letter cases. Look at this. How did I miss that? I path.append, all right? And then the path dives in, and then it should be truthy here. It should be truthy here. Yeah, so I got the single letter cases when it's a 2-digit. Why do I not have them when it's a 2-3? Oh, I do. Oh, it doesn't want them. Okay. Yes, that makes sense. I should not always add the path. I should only add the path if the length is, because it's a phone number. So it's not like 1 or 2 or 3-digit phone number combinations. It's only the 3-digit phone number combinations. Okay, so if path, so the guard should be like if the length of path is equal to the length of digits. And I feel like I even called that out earlier, but then I implemented it wrong. All right. Nope, I did something wrong here. If the length of path is the length of digits, man. Because I need that OG digit length, not the current remaining digit length. I need that OG digit length. I could just pass it through. It's just like one token, but I feel like that's the wrong thing to do. How could I do this? Oh, yes, because there is a path and there is not digits, both. So I should actually collapse these cases. If there are not digits, that means we're at the terminal node. Okay, and does this still handle the 0 case properly? I think so. Man, what did I do wrong? I'm grinding my own gears, team. Oh, I have like dog hair on me. All right. Why did DEF get on here? DEF. That would be in the 3 case. It should never be the case that D is the initial element of this list. It should always be ABC. So this bit is bad. So for char and cur option, no, that bit's okay. For I and rangeland digits, this bit is doing something bad. So then when I go to the 3, then I'm doing the DEF. And I'm getting remaining digits, nothing. Okay. Yeah, the algorithm is doing what I asked it to, but it's doing the 1 or 2 digit or 3 digit or 4. It's doing that or set, and I don't want that or set. So I think I can just eliminate this bit. I think I didn't need that. And so now there's no I. So I guess I would become 0 because we're only interested in the full case, the case where the starting index is 0 and we go all the way to the end. All right, now I did append the empty string. And so what is the reason that I did that? If not digits and path. I didn't add the and path bit. String index is out of range. Okay. I'm getting my falsy truthy combination handling there wrong. Okay. Let's see. Okay, we made it, team. Shubham, welcome. Yo, good morning from India, and wish me luck. I have an exam today. Good luck to you, sir. Thank you for being here. All right, team, we made it. So I don't know, follow the page and I'll see you for the next problem. If you found this interesting, you can watch the video from the top. It'll be saved on YouTube. That's my name, John Vandeveer, YouTube, at John Vandeveer. That's the Latterly YouTube channel. And you can go to latterly.io, sign up for free. You can join the community, join the Discord. You can ask us questions about backtracking there. And you can check out the new 5 orders of backtracking time complexity for interviews to understand how to optimize backtracking problems. Let's go.